Alright guys, so we're going to finish up the videos for this unit on fractions with talking about equivalent fractions, fractions that are equal to each other. Because just because fractions look different doesn't mean they're always different. Um, they can be cut into different pieces but actually equal the same amount. And it's really easy to visualize here with these two pies. If I look here and I take 2/4, so here would be one, two of those pieces, so 2/4, and I matched it up to there's 1/2 over here, I would see that 1/2 is the same or equals 2/4. So if I was to draw a line here and trace out these pies, and I was to slide this over, you would see that it's going to match up with 1/2 perfectly. You see they're the same size. I probably didn't even have to do that, and you can visualize how 2/4 of this pie, two pieces of this pie, when it's cut into fourths, is the same as eating half of that pie. Now it's really easy to visualize fractions that are equal when you see them like this, whether it be through pictures or fractional parts of a set like we've talked about. And really we've sort of seen some equivalent fractions already. You guys already sort of know what this is about. I'm just going to touch on it a little bit and then show you a way of how you don't need to have pictures, but you can figure out if fractions are equivalent or not. So let me just show you a couple other equivalent fractions that we have. Here we have, now this one may not look quite as simple and easy to compare, but we have pies cut in 6. So let's say I wanted to eat 2/6 of this pie, like this. Or better yet, let's go with 4/6 of the pie. So there's 2 pieces, and here would be 4 pieces of this pie. I bet you can already start to see what it would be equal to with the pie that's cut into thirds. So 2/6 equals how many thirds? And we can use fraction strips to compare this, or we can do what we did here with this pie to compare it. So I would take this first piece here. Looks like I'm going to have to twist it around a little bit to get it to fit. And I slid it in there. It's not going to fit perfect, but it'll be close. And I took this other piece and I twisted it around here to get it to fit in here. And for some reason it's not fitting perfect here. This pie on the right must not be the exact same size picture on the left. But you can see how it's pretty close to being the same, and I can tell you 2/6 would equal, well, not 2/6, I'm sorry, we changed that. 4/6, 4 pieces of the pie cut into 6, 4/6 would equal 2/3. And there's 1 2/3 is going to be the same thing as 4/6. And again, you can visualize this stuff and you can see how these fractions are equal pieces. But now let's talk about, well, how can we do that without drawing a picture? How can I figure out what is equivalent or not? And I'm going to use these 2 pictures to show you something that's equivalent and something that's not. And the first is going to be 1/4. I want to see if 2/8 is equal to 1/4. The way I want to start off is by taking my smaller denominator, and I mean the smaller digit denominator, not the smaller piece, but the smaller digit. So remember, 4 is a smaller digit. If you think about going back to our mathematical alphabet, numbers are made up out of digits. So 4 is the smaller digit. I'm going to go ahead and multiply it by a missing number to get 8. So I ask myself, 4 times what equals 8? And I know, because I'm awesome at my multiplication tables, because I did my racetrack homework, that 4 times 2 equals 8. It equals the denominator in this fraction. So now, if 2/8 is equal to 1/4, then if I multiply my numerator by the same number here, 2, then it should equal the same number over here. And if I look, 1 times 2 equals 2, so I can see that they are indeed equal. And just to show you a visualization of this, here is 1/4 that I'm going to hopefully trace better than I did last time. And I'm going to go ahead and match it up with 2/8 on this pie. And you can see how they fit, and they are a perfect match. There's 2/8 is the same as 1/4. Okay, now let's go ahead and delete this. Now I'm going to show you the same example using something that will not be equivalent. So this time I'm going to take 2/4 of the pie, and I want to know, well, is it equal to 3/8? And you might already be looking at the pie, well, and you might be saying, of course it's not, Mr. G. We already know 2/4 is 1/2. And 3/8, I can look at it, it doesn't equal 1/2. Alright, well, great. You guys are awesome. But I'm going to show you again using fractions we know. Okay? So again, if I take my smaller digit denominator and I multiply it by a number, it'll give me this denominator. So 4 times what equals 8? And again, we already know that's 2. We just went over that. So again, if I take my numerator and I multiply it by the same number down here, it should equal the numerator of the fraction over here if it's an equal fraction. What is 2 times 2? Well, 2 times 2 is 4, not 3. So this would not be an equal fraction. 2/4 does not equal 3/8. And I can show you. Actually, I'm not even going to show you because I know you guys can see that. Just look, visualize 1, 2, 3/8, and then these 2/4. You can see that this 2/4 is much bigger than the 3/8. Alright, so let's go ahead and look, and okay, not sure why I had that up there. That's alright. Let's go ahead and look at why this is important and how this works again. I can find any equal fraction to any fraction just by multiplying. Let's just take 2/3. Okay? I can multiply the bottom number, the denominator, by really any number I choose. And it'll give me, and if I multiply the numerator by the same number, then it will give me all sorts of equal fractions. So watch what I mean. Let's do 3 times 2. And 3 times 2 is 6. Okay? So now if I take 2 and I multiply it by 2, I'll get the numerator of 4. So 4/6 is equal to 2/3. They work. And I can keep doing this, guys. I can change the number all I want to find out. Let's say I did 3 times 4. Well, 3 times 4 is 12, so that's my new denominator. And 2 times 4 will give me 8. So 8/12 will be equivalent to 2/3. They're the same fraction, just cut up into different pieces. one has the 12 pieces in it, and we're talking about 8 out of 12, and this is we're talking about 2 out of 3 pieces. So if we had the same size pie and we had 2 of them, we cut one up into 12 pieces and one up into 3 pieces. 2 of those pieces would equal 8 of these pieces. Okay? So you might be asking, okay, why is this important? Well, it's important because I can use this to figure out if fractions are equal or not, like I just talked about. I can sit there and take any fraction and I can say, okay, let's figure out, 4/6, is it equal to, I want to know, is it equal to 8 12s? I don't have to draw any pictures. I can just say, okay, here's 6. What can I multiply 6 by to get 12? Because we're good, we know 6 times 2 equals 12. So now, if 8 12ths is equal to 4/6, if I multiply again my numerator by that same digit, 2, it should equal this. And 4 times 2 does equal 8. So these would be equivalent fractions. Let me give you one more example. Let's say we want to figure out, say, 13/24. Well, I can say 6 times what equals 24? I know that 6 times 4 equals 24. And 4 times 4, it does not equal 13, it actually equals 16. So 16/24 would be my equivalent fraction, not 13/24. Now that we look at this, I want you to think about this for a second. What does this help me decide now? Which one of these fractions is bigger? Is it 4/6 that equals 16/24, or is it 13/24? Think about that, and we'll talk about it tomorrow.